Hello guys, today I'm going to be doing a quick presentation on computing and problem solving. So that's what we're going to be going through today, so let's get straight to it. To start off with, what is computing? Well, computing is not like IT, it's similar but it's totally different. Well, I like to think of it like this, right? IT is like driving a car, whereas computing would be like let's say, how to, how to make an engine. So that's the difference between computing and IT, they're very different. Um, Computational thinking basics are made up of 4 main steps. First is decomposition, breaking up the problem, pattern recognition, recognizing the problem, pattern, and then generalization, and then finally algorithm design. So let's go through the steps. Firstly, decomposition. Part of being a computer scientist is to break down big problems into smaller ones so it's easier to understand and then it can be converted into code or algorithms. So let's take the quadratic equation as an example, right? If I could just get my pen out. Right. Okay, if you look at this right over here, this is a quadratic equation. We've all seen it before and we all hate it. But what you can do is you could break this equation up into little steps so it's easier to understand and quicker to do. Firstly, right, b squared. So, okay, we did b squared, we figure out b, we square it. Second, for AC, so we do the second step, we break up that, we figure this part out, and then we figure out the square root, and then finally we do the b minus b plus minus 1 over 2a. And it's a lot easier and a lot quicker to do. The second step was pattern recognition. So usually, like I said, when you have a big problem or a big pattern, you want to figure out what the pattern consists of or how it works. So we've got a pattern over here, quick sequence 1, 4, 10, 22, 46, 94, 109. So to work this out, what we do would be we'd work out on steps like say it could be 1 times 2 is 2, no, sorry, 1 times table. If I times 2 and add 2 it's 4. Oh, that works. Let's work again. 4 times 2 is 8, add 2 is 10, right? 10 times 2 is 20, add 2 is 22, and so on. So just then, as you saw, we just worked out the pattern, which was n times 2 plus 2 gives you sequence. Now then, the next one is pattern generalization and abstraction. Once you have the patterns, what we can do is we could turn into pseudocode, which makes it easier to understand for people. And pseudocode is closer to English rather than code. It's simple, so it's not rocket science or anything. And the final step is obviously algorithm design. So what we do is once we have the patterns, we have the pseudocode written, or we have the pattern just like that, and we decide how the code's going to work. We can decide on what the code's going to look like. So as you can see over here, declare robot. So we're calling a robot. Robot is a variable, saying it. Robot turn on. So we're turning the robot on. Robot get. So we're telling the robot to get the body. Robot to get the roof, and then what we're telling the robot to do is weld the roof and the body together until the weld is successful, and then turn the robot off. So as you can see, this is a simple algorithm, and this would consist of a few steps. Firstly, you'd have to look at a problem. So what we want to do is we want to get the roof of a car and the body and to weld them together. The second step would be to write some pseudocode for it. So get roof car, turn the robot on, tell the robot to. So we just write it in basic English style layout. And then finally, the final step would be to actually write the code, which is here. So that's all for today. So that's all for this lesson. Until the next tutorial. See you later.